On January 1st, 2026, weather satellites detected something strange. Short bursts appeared in the upper atmosphere that resembled neither a storm nor the general background. Worst of all, they coincided geometrically with the Earth 3I Atlas line. This isn't a case of someone's device malfunctioning. The signal is being seen by several independent systems simultaneously. Different channels, different algorithms, different processing centers. The anomaly repeats precisely at the moments when the object passes a sector convenient for Earth observation. The first thing that breaks the calm isn't the effect's strength, but its form. The burst starts abruptly, lasts 2 or 3 minutes, and then disappears just as abruptly. There's no tail, no gradual fade out. This isn't how processes generated by the weather or the sun behave. At 0317 UTC, a marker appears in the logs, a localized spike in electron density over the North Atlantic. 40 minutes later, a second one appears, over Scandinavia. An hour later, a third appears over Canada. The dots are different, but the pattern is the same. A short pulse along the line of sight. The on-duty engineer first does what any normal person would do. He looks for a trivial cause. A packet error, a loss of synchronization, a faulty filter, poor calibration. But trivialities die out when the same pulses arrive from a different network and using a different measurement method. At the same time, GNSS begins to behave in a non-threatening but unnatural manner. It's not on a scale that would cause planes to crash, but it's enough to increase signal flickering and fluctuate accuracy. The reports carefully call this short-term positioning degradation. If this were a magnetic storm, the picture would be broad and blurred. Here, it's the opposite. Narrow, localized, pinpoint. It's as if someone isn't pressing, but poking with a needle. And each prick lands in the corridor facing 3I/ATLAS. The most important thing, the space weather indices are calm. KP isn't screaming. There are no flares of the required class, and there are no well-timed coronal mass ejections either. The sun is behaving as if it had nothing to do with it that day. When you have an effect without a familiar source, the word external factor comes up in conversation. It's said without mysticism, dryly, almost angrily, because an external factor is something that breaks the instructions and protocols that have worked for decades. The first emergency call isn't called by romantic astronomers, but by technicians and operators. The Space Weather Center, ionospheric specialists, satellite engineers, the navigation team, and someone from NASA monitoring. And a separate group of people not listed in the protocols also joins in. The most direct question is asked within the first 5 minutes. Are we sure it's not the sun? Then begins the verification, which usually takes a day, but here it's done in an hour. They check all sources, all indexes, all event feeds, all warnings. At the same time, someone opens a window with geometry, where 3I/ATLAS is currently located, at what angle it views the Earth, which stations are in the line of sight, and then it feels like the numbers are playing tricks on you. The pulses are placed as if they were scheduled. They're trying to salvage the picture with the we're in our own way theory. Radars, transmitters, experiments, a saturated airwaves, they say. This theory sounds reasonable right up until the moment when the bursts are detected over the ocean, where there's no dense infrastructure, and the pulse shape is still the same. Then, there are things that look like silence from the outside. Inside, it's quite different. Access to raw data is cut off, distribution of graphs is restricted, and discussions are relegated to closed channels. Not because there's a conspiracy, but because any hint of communication with the target changes the status of the problem. Because if the bursts are related to 3I/ATLAS, then it's no longer just an interesting comet. It's a source that affects the communications and navigation environment. And that means it's a security issue. And at that point, any organization loses its sense of humor. Towards dawn, one analyst does something simple. He overlays ionospheric burst points on a map of the Earth object line of sight. The result is almost a straight line. He draws it manually over the map and posts it to a private chat. The caption is short, too clean. From here, a new phase begins. It's no longer why the bursts, but what exactly is passing through the corridor. They scan the spectrum for unusual radio emissions. They look for carrier waves, noise bands, repeating lines. Not a message, but simply the physics of presence. And here comes the second layer of alarm. The impulses aren't random, they're repeating. On the evening of January 1st and the morning of January 2nd, the pattern returns almost identically. It's as if the object is passing through the sector again, and once again making a brief check in the upper atmosphere. This is starting to look less like a side effect and more like a test. A weak pulse, a pause, another pulse, a pause, and the Earth responds with measurable changes in the ionosphere. Not a catastrophe, but telemetry. as if the planet is being carefully calibrated. On the second call, a phrase is heard that no one wants to say directly. It's said indirectly. It looks like a directional effect. Because if the effect is based on the line of sight, it resembles a beam, not a cloud, and a beam is no longer a coincidence. At this point, someone asks a question that turns the conversation violent. If this is a test, what happens next? And then they have no answer, only options. Bad ones, very bad ones, and ones no one even wants to formulate. While the public sees beautiful images and calm headlines online, internally they're starting to prepare what they always do in such situations. A recurrence plan, a list of vulnerable systems, monitoring windows, on-call duty, and additional monitoring modes. And the most disturbing thing is that they begin to anticipate the next sector pass. Because now it's not just an astronomical event, it's a schedule by which someone from outside is monitoring how the planet reacts when touched by an invisible hand. The first signal didn't come from astronomers. It was gleaned from weather satellite telemetry. A narrow band of the ionosphere boiled exactly where the Earth, 3I/ATLAS line, cut through the planet's night side. 5 minutes later, this was confirmed by other devices, unrelated to each other, different orbits, different frequencies, different algorithms. But the anomaly matched the geometry so precisely, it was as if it had been drawn with a ruler. It didn't look like a magnetic storm. Storms are always spread out, pressing down across latitude and time like a heavy blanket. Here, everything was localized, subtle, and, worst of all, repeatable, like scheduled impulses. Almost immediately, a side effect emerged that no one usually associates with comets. GNSS errors started creeping up. Not globally, not everyone's lost it, but locally. Streaks, short dips, as if someone had flicked a switch. On civilian maps, this looked like a small noise, easily attributed to software or poor reception. But in the closed logs of air traffic controllers, it was a significant event, because navigation errors are never pretty. At the same hour, communications operators detected a strange pattern in the HF range. Reflections from the ionosphere jumped as if the layer suddenly changed density in a narrow section, strictly along the calculated line to the object. And here a question arose that no one usually asks out loud. If it's not a storm or a random glitch, then what exactly turns on this line? Why does it only appear when the Earth Atlas geometry becomes perfect? NASA's public statements continued to talk about the normal dynamics of the upper atmosphere and the difficulty of forecasts, but internally they weren't interested in the forecast, but in the source, because the source was synchronous with the target. The most nerve-wracking thing began when independent radio observatories in different countries noticed the same thing. Short dips in sensitivity in identical windows, as if the ether became thicker for seconds and drowned out weak signals. In normal reality, this would seem like a coincidence, but coincidences end where the geometry matches, the timing matches, and the pulse shape matches, especially for devices with different physics. Then someone suggested a simple test, one that sounds almost silly until you understand the stakes. Don't wait, don't guess, but provoke a response. Schedule a series of observations and active measurements in a single window. They did what they always do when they're afraid of publicity. They split the task. Some observed the object optically, others listened to the radio, others monitored the ionosphere, and still others collected side effects on navigation and communications. And it was at that moment that 3I/ATLAS again acted as if it could see our alignment. The band in the ionosphere hadn't disappeared. It had shifted several hundred kilometers, remaining locked to the line to the object. It wasn't wind drift or a model error. The shift happened quickly and accurately, like moving a marker on a map. And the worst part is, it happened right after the experiment window went into private chat. Then came the second blow, silent but devastating for explanation. A sensor on one of the plasma monitoring satellites detected a series of overexposures, as if from a strong disturbance, but another satellite in orbit nearby saw the same thing. If this were natural activity, the picture would be wider and messier, but here it was kept narrow, as if it were contained in a corridor, and the corridor coincided with where we were keeping our eyes, on Atlas. And just as everyone was waiting for the next pulse to seal the deal, a different kind of black window arrived. Not telescopes, not footage, not press releases. Simply for a moment, a perfect piece of telemetry vanished, like a torn page. Then the data came back, but with a smooth, too clean seam, as if someone had reassembled the stream. And that was worse than any storm, because storms don't know how to clean up logs. They called it a triple layer window, not because it sounds fancy, but because there's no other way to explain what they were trying to do. Simultaneously see an object optically, hear radio waves, and measure the ionospheric response in a single geometry. The plan was brutally simple. If the line in the upper atmosphere is tied to Earth, 3I/ATLAS, it should repeat when the object passes the same sector relative to our night side. Then the pulse shape can be compared and the signature captured. To prevent anyone from later claiming it was just one station that crashed, they distributed the devices around the world. South America, Australia, Europe, Asia. Different networks, different teams, different servers, and the same point in time. The most important rule sounded almost childish. Don't share the schedule in advance. Send out the key at the last minute, even if the leak doesn't have time to adjust the picture. They already had a thought inside that no one wanted to say. With 20 minutes left until the window, a slight tremor began in the communication systems. It wasn't a malfunction, not a red light. The error statistics simply increased just enough for a human, not an automated report, to notice. One engineer wrote briefly, "Looks like preheating." And that was scarier than any alien comment because preheating signifies a deliberate action, not a random occurrence. At 217 UTC, the first ionospheric data showed a thin line of increased electron density. It flared on the night side like a scratch of light and extended along the calculated line toward the object, just like last time. After 40 seconds, the path tightened up as if someone had smoothed it out. It didn't widen or spread. On the contrary, it became narrower and denser. In nature, this isn't how storms behave, but how rays of light with a focal point behave. At the same moment, the radio telescopes experienced a strange phenomenon. The noise rose in a step and persisted for exactly 86 seconds. Not a wave, not a drift. An identical step on two continents using different equipment. The optics were supposed to be the key. If a microscopic change in brightness or coma structure appeared in the images at that very moment, the connection was not accidental. They switched to a short burst mode to avoid wasting seconds. And then, where they expected to see an ordinary comet, something appeared that defied description. It wasn't a flash or a tail. Within the coma, a thin arc appeared for a split second, like the trail of a ring. The arc was faint. So faint that on one telescope it could have been dismissed as an artifact. But on the second, with different optics and a different camera, the arc fell into the same angle, with the same curvature and almost the same radius. When the two frames were compared, silence fell. Not a pause for drama. The silence of a man who realized he had just seen not beauty, but instructions. The arc had the shape of a carefully calibrated template. A minute later, the arc vanished, and the track in the ionosphere vanished. Not gradually, not like a fade. It simply switched off, as if someone had pressed a button, and that was the point after which no one uttered the word storm. The internal meeting was held unprotocol-free. No long introductions, no colleagues. Good evening. The first question was straightforward. How many independent confirmations do we have for the same second? The answer sounded worse than a death sentence. 2 optical coincidences, 3 radio coincidences, 4 sets of ionospheric data, and a separate channel from navigation, where errors increased precisely when the beam passed through the night side. They tried to find a terrestrial explanation out of anger, not skepticism. They looked for everything: local radio interference, software glitches, calibration issues, human error. But each time they hit the same wall, the geometry matched. Then someone suggested a second test, a dangerous one. Instead of passively observing, they would illuminate the atmosphere with active probing, to see how the response would change if the frequency and mode were switched on at an unexpected moment. This is exactly what they do when testing a system's response to a stimulus. In conventional science, this is called an experiment. Here, it was like a knock on the door at night, when you're not sure there's even a person on the other side. At 0304 UTC, they activated a mode that wasn't originally planned. A frequency change, a short burst, a different angle. If there's nothing out there, the atmosphere will behave normally. If there is someone out there, they might react. The reaction didn't come hours later. It came 19 seconds later. And it didn't come as a response signal, but as a change in the environment. The path in the ionosphere unfolded, as if turning its head toward a new source of attention. It wasn't a mirror, it looked like a correction. Seconds later, the radio noise returned in steps, but with a different duration, as if the system had recalculated the parameters and applied a new suppression mode. And again, a small, palm-chilling thing happened in the optics. The coma became momentarily asymmetrical, as if the direction of the ejection had been switched within the object, but so subtly that it didn't look like a stream outwardly. There was no joy in the room where the analyst sat. Joy comes from capturing a rare comet or a beautiful spectrum. Here, it was a different feeling. You had become a participant in a process that didn't ask you to participate. The most unpleasant discussion began later. If an object is capable of shifting a disturbance through the upper atmosphere, then it is acting either with a field, a particle beam, or something we don't yet know how to name. And if it can do this, then it knows how to choose exactly where to do it. And the choice of the Earth object line speaks not of chance, but of purpose. It's as if they're testing us as an environment rather than space. After this, the question, why do large observatories sometimes go blind at precisely the right hour, ceased to sound like a theory. It became a logical extension, because if you can touch the ionosphere, you can touch sensitive electronics. That day, a phrase appeared in an internal memo that would later be tried to be deleted from the archives. We are no longer observing the phenomenon. We are interacting with the system. And no one disputed the meaning. They argued about what to do next. They showed up for the next call as different people. No unnecessary words, no attempt to calm the team. The question was the source of the influence within 3I/ATLAS itself or nearby, as a separate structure? If this is an object's aura, then the line in the ionosphere should be diffuse and inertial. If this is a directed action, then the front will begin arriving at the stations with a time difference, and from this difference, a rough geometry can be constructed. They set up 3 independent observation grids. The first was GPS tech, covering the entire globe to observe electron density. The second was ionosondes and radars, where access was restricted. The third was radio telescopes at different frequencies, and most importantly, they agreed not to look at each other until the end of the window, not to discuss intermediate results, not to post graphs in the general chat, only raw timestamps and control file hashes. At 4:12 UTC, the same thing happened again, but differently. The ionospheric track didn't appear all at once, but seemed to crawl along the night side, leaving a thin trail behind before disappearing on the other side. The time difference between the outermost stations was too precise. Not approximately, not plus or minus. It followed a sequence that could be approximated by a moving source. Someone immediately said what everyone was thinking. If it is a moving source, then it is either rotating and sweeping a beam, or there is a separate object nearby that is scanning while the main body maintains its course. They did what they usually do with thunderstorms. They started mapping the front's velocity. But the thunderstorm doesn't maintain a line tied to the Earth object geometry. It doesn't maintain a consistent angle and can't be turned off with a button. When the calculated front was superimposed on the 3I/ATLAS ephemerides, a strange detail emerged. The maximum impact did not occur precisely through the center of the calculated line, but with a constant lateral shift, the same from window to window. It was a millimeter on the map, but kilometers in reality. Too stable to be a mistake. Too stable to be the wind. The shift looked like a parallel path, as if there was a second channel nearby. And here's where things got really nasty, because a parallel channel means the effect comes not from the object, but from something held next to it at a fixed angle. They pulled up old data from previous days and ran the same algorithm. The pattern repeated itself. The parallel track had been present before, but it had simply been dismissed as noise because no one was looking for the second line. A hypothesis was put on the table, one that's usually kept in mind and not spoken out loud. Not a single object, but a cluster, the main bright one, the one observed by civilian astronomers, and the second, the faint one, which is only revealed through effects. To avoid going into fantasy, they did the only honest thing. They tried to calculate where the second should be located if it gives a fixed angular shift and the same front dynamics. The calculation yielded a sector in the sky, close to the coma but slightly off to the side, where optics are usually clogged with stray light and processing. And coincidentally, there were a couple of reports of a point source without a catalog in that same area. These messages used to be drowned out by a single phrase, satellite or glint. Now this phrase no longer works, because the satellite doesn't sit at the same angle relative to the comet on different continents and doesn't create a synchronized ionosphere. Then they did something that makes scientists laugh nervously. They asked private filmmakers, not out of romanticism, but out of pragmatism. Private filmmakers shoot differently, process differently, and they don't have the corporate make it look good filter. 3 people received coordinates and timings 10 minutes before the window. 2 in Europe, 1 in South America. They weren't told what to look for. Just one thing, shoot in bursts. Don't use noise reduction. Save the raw footage. At 4:38 UTC, one of them in the series showed a star next to the coma, not where the star is listed in the catalogs. At 4:38:27, the second one showed the same thing. Not identical in brightness, but the same relative position relative to the comet. The third saw nothing, and that was even better, because the third was at a different angle, and his line of sight passed through a brighter patch of sky. So the effect was geometric, not mystical. When the 2 frames were superimposed and time-stamped, they coincided with the moment when the parallel ionospheric path reached its maximum. That is, the point source and the second channel existed in the same instant. After that, the term false star became not a metaphor, but a working term. It was as if they had a name for something they couldn't name publicly, but had to work with internally. And then the most pressing question arose. If there's a second object near 3I/ATLAS, why aren't major observatories detecting it? The answer was ugly, because it explained everything at once. Because major observatories take images correctly. They subtract background, filter noise, remove artifacts, and standardize the image. But a false star looks exactly like what the algorithm is used to rejecting. It's too small, too brief, and too much like a glitch. And if you have a rule that says, don't publish anything questionable, you're blinding yourself without even realizing it. You're literally erasing the object from the data. They tried to double check on their end, not trusting private companies. They took raw footage without running it through the standard pipeline, and in the same sector, they saw a hint. Not a single dot, but a microscopic compaction in the noise. It was worse than a dot. A dot can be written off as a pixel. The compaction in the noise means the object is faint but real, and it's embedded in the very structure of what we consider a coma. At the same time, another group was digging into weather satellite telemetry. They weren't looking for a storm, but for a repeatable response in the upper atmosphere along a line related to geometry, and they found another spike. This time on the day side. The day side is always more complex with the solar background, but the spike was localized and rapid. It looked as if the conductivity in a specific atmospheric corridor had been altered and then reversed, leaving no trace. And again, the timing coincided with the false star's appearance in the individual series. It was a disturbing unification. Optics, radio, the ionosphere, and weather satellites were all telling the same story but in different languages. At the end of this window, a map hung on the wall, and on it were two lines. The first was a direct Earth 3, I/ATLAS connection, expected and logical. The second was parallel, offset, as if a second beam were running nearby. And then came the phrase that put an end to the natural explanations. If it's scanning, then it must have a step. A step in time, a step in angle, a step in frequency. Every scan has a rhythm. They constructed a rhythm spectrum across several windows, and they achieved repeatability. Not perfect, but recognizable. Like the breathing of a system that performs the same action over and over again, until it gets the desired response. The next solution was risky. Create a dummy target. Change the active sensing parameters to make it appear like a different source, and see which way the ionospheric track would turn in response. If the track turns again, it's not a passive plasma effect. It means someone is perceiving the stimulus and adjusting the vector. It's no longer a comet and solar wind scenario, it's a feedback scenario. At 0507 UTC, they did something that in normal science is considered almost indecent. They didn't collect more data. They pressed a button and changed the signal's parameters so that it looked alien, not stronger, not brighter, just different. The idea was simple and brutal. If an ionospheric path emerges on its own, it doesn't care what you turn on. It will live by its own laws. But if the path is the answer, then it's bound to waver, like a compass needle near a magnet. They chose a narrow window when the Earth 3I/ATLAS geometry was perfect, and when, according to their calculations, the star spur should reappear near the coma for at least a few minutes. It was precisely these minutes that the test was designed for. The signal was switched smoothly, without a sharp transition, to avoid creating commonplace man-made interference. Then, control marks were recorded, and each network node began writing data to a separate container to prevent anyone from retroactively tampering with the logs. The reaction didn't come immediately, and that was the worst part. The silence lasted almost 9 minutes, and in those 9 minutes, everyone managed to convince themselves that they were nervous for nothing, that it was just a statistical game, that the brain was inferring meaning where none existed. And then the track shifted. It didn't disappear, it didn't get stronger. It simply shifted sideways at a constant angle, exactly the same parallel shift they'd previously attributed to data noise. Only now the shift occurred after the switch. They looked at the graphs and realized this didn't look like plasma. Plasma doesn't reconfigure itself to match someone else's signature. Plasma doesn't wait 9 minutes and then carefully rebuild the line as if it had recalculated the geometry. The first to speak wasn't the theoretician or the boss. It was the communications engineer, a lifelong believer in hardware. He said succinctly, either it's the algorithm or we've all gone crazy, the whole shift. A minute later, a second strike arrived, this time visually. A private operator in Europe, the same one who had filmed in bursts without noise reduction, sent footage. A false star had appeared, but not where it had been the last time. It had also shifted. There was a moment when the room became very quiet. Because two independent channels, the atmosphere and the optics, made the same movement after the same action on their part. It looked like a response to a test. They immediately stopped the experiment and reset the parameters. Not out of caution, out of instinct. When you poke a stick into the darkness and the darkness poke you back, you stop pretending to be brave. What remained was the simplest and most terrifying thing, to catch confirmation from above. Not amateur footage, not indirect effects. I needed an instrument that everyone believed in. I needed space. I needed Hubble. The window was calculated in advance. The geometry was ideal, the background was tolerable, and a series of short exposures was expected where a point source could emerge even against the coma if it were truly close to the object. And at that very hour, Hubble went into safe mode. Not someday, not at night, not after a series, right into the corridor when the star dummy should have been best visible, if it even existed. At first, it seemed like a twist of fate, then like a coincidence that just seemed too awkward. And then they opened the telemetry and saw a pattern that usually makes people break out in a cold sweat. Before entering safe mode, the sequence of events was identical. A slight increase in errors, then a brief power failure on one channel, then 2 warnings in a row, and only then did the system enter protective mode. The problem wasn't that Hubble broke down, it was the repeatability. If it had been a random glitch, the logs would have looked like chaos. But there was a rhythm, a short ramp to shutdown, as if someone was testing the limits. They retrieved the archive from previous windows, when Hubble was also blind, at an inconvenient moment, and found the same staircase. The same steps, the same intervals. The only difference was that this time, everything happened faster. Within NASA, 2 parallel realities emerged. In one, the public one, it was a routine technical failure, a preventative transition, a standard equipment protection. In the other, internal one, it was a question. What exactly was causing the staircase? Because if the staircase repeats, then so does the cause. And if the cause coincides in time with the observation window of the false star, then this cause has geometry and isn't just random. That same night, they attempted something previously considered too daring, comparing the moments leading up to failures with the telescope's orientation. Not where it's looking in the sky, but what its field and load profile is. The alignment proved tricky. The pre-glitch occurred when Hubble's orientation passed through a very specific set of angles, and these angles coincided with the sector containing the calculated parallel channel near 3i/ATLAS. They didn't say influence, they said correlation, but it was the same word, just gloved. Correlation meant that the telescope behaved differently when it looked in the direction where the second object should appear. Against this backdrop, the ionosphere again left its mark, a thin line, shifted as if a second beam were nearby. And this time, the line didn't just appear, it twitched as Hubble entered safe mode. It was as if someone had noticed the attempt to look and pulled the emergency brake. Not turned everything off, not blinded the planet, but precisely removed the one instrument that could provide clear confirmation. They tried not to get carried away by fantasy and did what only sane people do. They checked alternatives, solar activity, background radiation, known equipment problems, and failure statistics over the years. The alternatives explained a lot, but they didn't explain the timing. They explained the possibility of safe mode, but they didn't explain why safe mode occurs precisely during the window where a false star recurrence and maximum observational purity are expected. By morning, they had a package of documents that couldn't be sent through regular channels. It contained logs, timestamps, offset calculations, private footage, and a short half-page note. The note was uncomfortably calm. It didn't contain the words anomaly or impossible. It simply stated, subject is showing signs of a reaction to surveillance. It is recommended to limit active investigations until risks are assessed. And this was the first time the word risk was mentioned in their correspondence, not about reputation or budget, but about physics. About the fact that the test might not be one-sided, that the test might turn out to be an invitation. It all started not with a loud order, but with a quiet wording in an internal newsletter. Temporary pause in publishing raw footage until calibration is complete. A normal phrase for a normal situation, but this time it was sent not to the scientific department, but to everyone, including the night shift technicians. 10 minutes later, a second email arrived, this time without diplomacy. Close observation windows for Sector 3I/ATLAS. Reject requests from external teams. Run all source files through the updated pipeline. Do not distribute raw footage. And at the bottom, the signature was not from the research center, but from mission control. The most annoying thing about such orders isn't even the prohibition. The most annoying thing is that it comes not after the failure, but before the explanation. It's as if someone knows in advance that the explanation will be too difficult and is trying to buy time. The engineer who saved the raw data was no hero. He wasn't trying to expose the system, and he didn't dream of being the one to tell the world everything. He was simply one of those who doesn't believe in perfect calibration until he's seen the source, and he was right there with the storage system when the order came. He did it casually, almost lazily. He duplicated the raw exposure container onto a separate drive, labeling it not Atlas, but with a technical code so that even he himself wouldn't be able to find it right away, and only then, as expected, launched the updated pipeline on the official server. The difference wasn't immediately apparent because the official image now looked cleaner. The coma was smoother, the background was calmer, the noise was muted, and there were no strange pixels. It would have looked perfect in publication. It would have looked exactly as the sky should look when nothing is happening. But when he opened the raw footage on his local machine, the picture was different. Not brighter, not more detailed. The logic itself was different. As if two sets of data were describing the same place in the sky, but in two different versions of reality. The false star was there. The point source, uncatalogued, was again hovering relative to the coma, but that wasn't the strangest thing. The strangest thing was that it didn't appear smoothly, like an object in the background, but in steps, as if it were turning on in discrete stages. In one exposure, it's barely noticeable. In the next, it intensifies dramatically. In the third, it almost disappears again, but not weakened. Rather, it seems to shift a fraction of a pixel and return to the same point. It doesn't look like a satellite. The satellite is moving along a track. It doesn't look like a lens flare. The flare is dancing with the optics. He zoomed in on the image to the point where any normal person would stop seeing the star and start seeing a series of squares. And it was there that he discovered something else. There was a barely noticeable halo around the dot, too regular to be noise and too symmetrical to be a random background. He did what techies do when their brains start making sense. He compared the raw image with the processed image. In the processed image, there was no halo. The dot looked like an artifact, like a dirty star, like a fluke. In the raw image, it looked like structure. He didn't tell anyone, "This is it." He simply sent a short message to two people he trusted without emotion or any mention of aliens. There's a difference between the raw and the pipeline. Looks like it's been cut around a point. Need a second look. The answer came almost instantly, and it was worse than any yes. It was. Don't write this in chat. Don't send files. I'm coming to you. While the second man was driving, other conversations were going on above. They had already realized that the problem wasn't just with Hubble, because through the same window, several ground-based observatories had done something strange. They were producing empty frames, despite perfect geometry. Not bad pointing, not clouds. They were empty, as if the object had disappeared. At first, this could be chalked up to coincidence, but when we started reviewing the logs, the coincidence began to look like coordination. At the same time, different tools encountered the same problem. The object disappeared, but the background remained perfectly normal. This is that black window that makes you uneasy. If the telescope missed, the background will be different. If the exposure was off, there will be noise. If a cloud obscured the field, there will be a gradient. Here, everything was clear, only the target was missing. Then, for the first time, they uttered a phrase out loud that they usually don't even say jokingly, as if he can be invisible to a specific procedure. Not to the eye, not to all the instruments, but to the set of methods we use to try to remove him. And here's where those who don't usually show up on scientific conference calls came into play. Because alongside the blank frames, another layer of data surfaced on the closed radar channels. A reflection. Stable, repeatable, with a character unlike a dust cloud. Citizen astronomy saw the comet and its coma activity. Radar saw rigidity. Not the shape, not the image, but the way the signal returned. And this return was too precise. It maintained its frequency and phase, as if it were reflecting not from chaotic dust, but from a surface or a lattice. This doesn't mean ship. It means that according to radar data, there's a component that behaves like a structure. And when this component appeared, silence ensued. Windows were closed, access was cut, publications were delayed without explanation. People in science are rarely afraid of a fact. They're afraid of a cluster of facts. When one layer of data pushes another, and you realize it's not just one instrument that's gone crazy. It's different instruments showing the same clue from different angles. The second engineer arrived without further ado. He sat down next to me, looked at the raw footage, and was silent for a few minutes. Then he said, "If this is an artifact, it's too stable." And that was the coldest confirmation one could get. They tried the most basic test, shifting the frame, changing the exposure order, applying different calibrations, and running the camera without noise reduction. The dot remained, the halo remained, and most importantly, the step-switching logic remained as if the subject weren't constantly illuminated, but were instead firing in pulses. And it was at that moment that the third letter from the top arrived. Delete all local copies. Account for all external media. Consider raw files temporarily restricted. Violation of procedure will result in disciplinary action. It was written dryly, but the message was clear. They already know. After that, every action began to feel like a choice. Either you submit and pretend you didn't see anything, or you keep the evidence and become a person who knows too much. And not too much for science, but too much for the system of governance. The engineer looked at the second drive, where the raw footage was stored, and didn't overreact. He simply hid it, not in a drawer or a bag, but somewhere they had no formal reason to look, where consumables, cables, and old fasteners usually lay. After that, they returned to the main question of the night. If a false star really is hovering near 3I/ATLAS, what is it? A satellite, a knot, a cloud, or a second object that accompanies the primary one and acts as a separate element? And then an idea occurred to them that was disconcerting, not because it was fantastical, but because it was too practical. What if the false star wasn't a light, but a marker? Not something we see, but something we are seen with. Because that same night, the ionosphere produced another line. Not a general storm, not a background, a localized spike along a path that coincided with the Earth object line. And the spike arrived precisely when the dot in the raw footage had become a step higher. It looked like synchronicity, as if an impulse there was producing a response here. And if that's true, then the false star isn't a side effect. It's an active node, working in conjunction with the object in our atmosphere. The most terrifying thing about such connections is that they change the human role. You're no longer an observer, you're part of an experiment. You press a button, and the system on the other side reacts, leaving a trace in your atmosphere, in your instruments, in your data. The worst thing about that night wasn't that they found an extra point. The worst thing was how quickly the system above reorganized, as if it already had a ready-made scenario in case someone saw more than they needed. They weren't arguing over whether the false star was real. They were arguing about something else. Was the connection real? Was there a coincidence between its pulses and what was happening in the upper atmosphere? Or was it simply the brain, beginning to stitch events together into a pattern? The test had to be as blunt and independent as possible. No fancy algorithms, no improvements. One parameter: time. If the dot is activated in stages, it should be visible not only in the optics. They had a contact in radio surveillance, a man outside of their chain, and that was important. He didn't follow their orders. His instruments didn't follow the same pipeline. He had his own logs, his own raw recordings, and his own habit of disbelieving coincidences. They sent only one thing: no files or images, a time window and sector coordinates, plus a request: shoot continuously, no filters, no averaging. We need the raw stream. It seemed innocuous, like a routine request from colleagues. The answer came 20 minutes later, too quickly for a normal cycle of observation and processing. And that's precisely why it struck a nerve. I see a pulse, not noise, repeatability. The period is almost constant, like someone is clicking a mode. This was exactly what they were afraid of. Because optics can lie, they can flicker, they can pick up stray reflections. Radio in this configuration is harder to lie. If there's rhythm, then the rhythm exists in the signal. They asked for clarification without betraying their emotions. What's the frequency? What's the pulse duration? Is there drift? The man on the radio sent numbers, and the numbers were colder than any text. The pulses were short, but uniform, and then a connection formed that made you want to step away from the monitor, because the pulse duration almost coincided with the duration of the black window when the observatories produced blank frames. Not a minute more, not a minute less, almost like a marker. No one shuts down different telescopes for the same duration by accident. Each has its own protocols, its own failures, its own causes, but a uniform shutdown duration doesn't look like a problem, but rather like a regime. At that point, they stopped talking about artifact. They started talking about behavior, because behavior involves choice. Choice of timing, choice of form, choice of what to show to whom and when. Inside NASA, they sensed it too, even if no one said it out loud. The emergency call was held not as a scientific meeting, but as a crisis. Too many people in the frame, too few jokes, too many pauses as everyone waited for someone to say the forbidden thing first. Officially, there was a discussion of a calibration anomaly and pipeline inconsistency. Unofficially, there was a different discussion. Why independent tools simultaneously lose an object at the best moment, and why the thing accompanying it behaves like a switch. The finest line there was the word connection. Until there's a connection, it's a collection of oddities. As soon as there's a connection, it becomes a system, and a system requires a different protocol. Not an academic one, but a managerial one. On that call, someone said out loud what's usually said in a whisper: if it's a probe, it doesn't have to be comfortable. The phrase wasn't meant as a dramatic gesture, it was an attempt to regain control by calling the thing by its proper name. At the same time, another screen showed ionospheric graphs. There was a line there again. Not a planetary storm, not the general background, a narrow band of excitation, as if someone had drawn a ruler across the atmosphere, matching the Earth object geometry. And the most disturbing thing, the stripe didn't appear continuously. It pulsed. The rhythm was like that of a radio signal, and the more precisely they aligned the timing, the less room there was for reassuring explanations. In such cases, the official spokesperson always says the same thing. Observations are ongoing. Data is insufficient. No unusual threats. These words are spoken lightly because they are not intended for those who look at graphs, but inside the room, decisions were made in different terms. Cut access. Limit publication. Move windows. Check who has local copies. This doesn't sound like science, it sounds like defense. The strangest moment came when they tried to repeat the experiment deliberately. Rather than waiting for the subject to do something on its own, they tried to provoke a reaction. They chose a window and simultaneously raised several instruments in one sector. The idea was simple and wicked. If the false star reacts to observation, then the amplification should coincide not just with the time, but with the start of the coordinated session. That is, with the moment when the network of telescopes becomes a single eye. They didn't even have time to complete synchronization. The radio pulse arrived on the graph before the start marker lit up in their system. The difference was small, but enough to stick in your head like a splinter. It can't be explained by a reaction. The reaction comes after. Here, it looked as if the impulse was not a response but a warning, as if the subject knew they were about to look even before they started looking. Then things got really unpleasant. In some optical frames, the object didn't disappear. Only the coma around it disappeared, as if someone had cleaned up excess dust and left the bare core, and even then, not everywhere. The picture varied across different instruments. It looked like a kernel swap, but now they could see the mechanism. Not just different shapes in the images, but different versions of what was considered the kernel after processing. In some places, the pipeline smoothed out the structure. In others, it emphasized it. And here's where the key question, which no one wanted to ask, came up. If processing can remove the halo around a false star, then someone knows what to remove. And if someone knows what to remove, then it's no longer a mistake. One of the engineers on the call asked as calmly as possible, "Who approved the pipeline update and why was it released today?" The question hung in the air because it couldn't be answered honestly without destroying trust. The answer was bureaucratic. A routine update, but the log showed otherwise. The commit had been rushed. The edits affected precisely those modules that cut out small, symmetrical structures around point sources. That is, someone had pre-cut a knife to a specific pattern, not just noise in general, but a specific geometry. And this wasn't about space anymore. It was about people who decided that society shouldn't see what they saw. While they were arguing over the data, another oddity surfaced from the other side. The military radars were once again producing a stable reflection, but now it was breathing, in phase, with the pulses. It wasn't simply present or absent, it was changing in stages. It looked like the structure was rotating or changing its surface state. Not like a cloud dissipating, but like an object switching modes to interact with the signal differently. And then it became obvious why the black window was so uniform in duration. These weren't telescope glitches. It was a period when the object entered a state where some methods simply stopped seeing it. Not invisibility, as in magic. Invisibility as a careful selection of what to reflect, what to absorb, what to dispel. As if he understood our instruments well enough to choose what to show them. At this point, the conversation within NASA became divided. Some wanted to expand the observations and squeeze out as much as possible while the object was nearby. Others wanted to stop, because stimulating a system you don't understand is a bad idea. And then a word was uttered that usually only appears in movies, but here it was technical. Scanning. Because the jets and pulses, the line in the ionosphere, and the reflection steps formed a scan pattern. It's as if the object is taking measurements. It's checking the atmospheric response, checking reflectivity, checking how quickly we assemble the network, and how we change modes. And it's not doing this randomly, but in a repeating sequence. At the end of the call, a decision was made that seemed minor, but was a sign of panic. Publicly, we'll talk about routine outages and solar activity. Internally, we'll work according to a closed protocol. That was the official line. But the engineer below had a different, simpler line. Keep it raw, because tomorrow they'll rewrite it all. And he understood that the risk was no longer that he was wrong, the risk was that he was right.